Hello guys and welcome back to MathZone. In this video, we are going to learn about the theory and the formula of circular measure. So let's get started. The first one, we are going to learn about how to measure an angle. Usually, we use degree, right, to measure our angle. For example, you use protractor and then you measure how many degree is your angle. So we have some example here to recall your mind. So we have the first one, we have two lines that are perpendicular to each other. We say that the angle between them is 90 degree. Or if we have a line, our angle is 180 degree. Or if we have a circle, one full rotation, we say that the angle is 360 degree. Now, in this chapter, we will focus on measuring our angle using the second way, which is radian. Now, let's learn what is radian and how big is 1 radian. Now, radian is just another way to measure our angle. So, let's start with a circle. I have a circle with radius r. Now, I want to create an arc length that is equals to its radius. So for example, our radius of our circle is 1 centimeter. That means I want to create an arc length that is 1 centimeter equals to its radius. For example, our radius is 3 centimeter. That means our arc length also 3 centimeter. Now, if my arc length equals to radius, that means the angle created by this arc length will be 1 radian. So 1 radian is the angle. How big is this angle? 1 radian created by the arc length that is equals to radius. So whenever you create an arc length that is equals to its radius, if the radius is 5 centimeter, you create an arc length equals to 5 centimeter. The angle created by that will be 1 radian. This is radius, this is radius, this is radius, but arc length. Your angle between these two radius will be 1 radian. Now, we already know how big is our 1 radian. But the next question is, how many radian do we have for one full circle? So, let's look at this circle. We already know that when we have arc length equals to 1 radius, it will create 1 radian in angle. Now, what if I take my arc length equals to its circumference, which is the full circle? We already know the formula of the circumference. The length of this circle is 2 pi radius. So, when we just use comparison here, when we have 1 radius, it will create 1 radian, the angle. If we have 2 pi radius, that means I create 2 pi radian. So if I have 2r, that means I have 2 radian. 3r, 3 radian. If I have 2 pi, yeah, my radian will be 2 pi as well. So by knowing this fact, we can say that for one circle, let me change color first. For one circle, it is 2 pi radian in angle. In degree, we say it equals to 360 degrees. So 2 pi radian equals to 360 degrees, which is one circle. That means if I take only half circle, I have pi radian equals to 180 degree. By knowing this fact, we can know how to convert degree to radian and radian to degree by using this convention. Pi radian equals to 180 degree. So, if I want to convert from degree to radian, you multiply with pi over 180 degree. On the other hand, when we want to convert radian to degree, we multiply 180 degree over pi. So keep in mind that if you want to convert degree, make sure that the degree is in denominator, and we want to convert to radian, that means the radian is on top. is on the is on the numerator. The opposite, if you want to convert radian, make sure that the radian, which is the pi, is on the denominator. And because we want to convert it to degree, make sure that the degree is on top. Okay, so let's look at example here. Let's say I have 90 degree. I want to convert to radian. So that means because I have degree here, I put my degree on denominator, 180 degree, and then the radian on top because I want to convert to radian. So you will get pi over 2 because 90 and 180 degree divided, it becomes 2 here. When we have, for example, pi over 4 radian, I want to convert to degree. That means I put radian, the one that I know, put it on the denominator, which is pi, the radian, and the one that we want to convert it to radian, to degree, so we put degree on top, 180 degree. So you can cancel the pi, and you get 180 degree divided by 4. You will get 45 degree. So if you want to convert to radian, put pi on top. If you want to convert to degree, put 180 degree on top. That's how you convert degree to radian. Now, we are done with radian. Now, why is it important? Why don't we just use degree? Because by using radian, we can calculate the arc length and area of a sector easier. So, let's look at arc length first. We already know that the arc length is part of the circumference. This is our arc length. Arc length is just part of our circumference of the circle, the length of this arc. Now, because we know that for 1 radian, the length of the arc is 1 r. 2 radian, 2 r. 3 radian, 3 r. If I have theta radian, the length will be theta r. So the formula of the arc length is just theta times r. Theta is the radians, the angle in radian, multiplied by its radius. It's very easy to memorize. Arc length equals to radians times radius. The radius times the radian. You will get the arc length. The second formula, we can calculate the area of a sector created by an arc length. So this is the area of a sector that you want to find. The area may be like a slice of a pizza. This is like a full pizza, and you want to find the slice of the pizza. What is the area of this? You can use ratio. The area of a sector that you want to find over the area of a circle, the full circle, equals to the ratio of its angle. Area of a sector has an angle theta. The area of a circle, it has an angle 2 pi in radian. So the ratio of the area will be equal to the ratio of the angle. Now, because we know that the area of a circle equals to pi r square, right? So it equals to theta over 2 pi. And then you can multiply both sides by pi r square. So we can get area of a sector equals to theta over 2 pi multiplied by pi r square. Now we can cancel the pi over here. So you will get the formula of the area of a sector that you want to find, which is 1 over 2 theta r square. So the second formula that we will use is area of a sector equals to half theta r square. So keep in mind that we have two main formula for this chapter. The first one is the arc length, theta r. The second one is the area of a sector, which is half theta r square. And keep in mind that the theta must be in radian, not in degree. Now, if you look at the past paper, you will find not just a circle, but also lots of triangle. So for this chapter, there are some useful trigonometry formula that you have to know and then know and understand how to use it. So later on in the past paper, you will find a lot of triangles, but I can categorize them into two types. The first type is right angle triangle, and the second one is not right angle triangle. Later on, if you find past paper and you have right angle triangle, you can apply these three principles. The first one is the Pythagoras formula, and you already know that it's c squared equals to a squared plus b squared. When you have right angle triangle, c is the hypotenuse, this is a and b, can be any, and then this is the 90-degree that you have, and you can apply the Pythagoras formula. The second formula is the SOHCAHTOA formula, which is sine theta, cos theta, and tangent theta, that we're going to discuss soon. And the third one, if you are asked to find the area of the right angle triangle, just use this formula, base times height over 2. This is the base, this is the height, and then just divide by 2. You can say like a times b over 2, same thing. But on the other hand, you may find not right angle triangle. If you have not right angle triangle, let's say I have this triangle, yeah, you cannot use Pythagoras because it only applies to right angle triangle, and you cannot use SOHCAHTOA as well, but we can use sine and cosine rule. Later on, I will discuss about that. And the area is easier to use the sine formula. You can still use area equals to base times height over 2, but it's harder because you need to find the height first. This is the base, and remember the height is just 90-degree to the base, and most of the time you will not have this height given in the question, so you have to find it, which is harder and much easier to just use sine formula. Now let's focus on SOHCAHTOA first. SOHCAHTOA, by using SOHCAHTOA, you can remember sine, cosine, and tangent formula. So in a right angle triangle, you can apply SOHCAHTOA. SOH stands for sine theta formula. So S sine theta equals to opposite O over hypotenuse. So when you have right angle triangle, this is your theta here, and the side that is opposite to its theta, we call it opposite, and you divide with the hypotenuse, which is the longest side in our triangle. When you divide opposite with hypotenuse, you will get sine theta from sine theta value. The second one, we have CAH, stands for cosine theta equals to adjacent over hypotenuse. So you can divide the side that is next to theta, we call it adjacent, divided by hypotenuse, you will get cosine theta. And the last one, when you divide opposite with adjacent, you will get tangent theta. So by knowing this, you can solve problem easier later. Once again, this only applies for right angle triangle, but what if we have not right angle triangle? We can apply sine and cosine rule. Let's look at the first rule, the sine rule. For the sine rule, before I explain about the formula, I prefer to understand the formula rather than just memorize the formula. So let's look at how do we apply the formula. How do we use the formula? We have to know how to label triangle first. So how to label the triangle? Let's say I have a triangle here. Oh, keep in mind that sine rule and cosine rule also applies to right angle triangle. But for right angle triangle, it's easier to use Pythagoras and SOHCAHTOA. But if you want to use sine and cosine rule to right angle triangle, it also works, because sine and cosine rule works for all triangle. So let's say here I have a triangle. Let's label three angles here. Let's label it as A, B, and C. And when you label angle, you have to use capital letter A, B, and C. And then after you label A, B, C, maybe I can erase this first. After you label the angle A, B, and C, the side that is opposite to angle A, we call it as side A. For side, usually we use lowercase. And then for B, the side that is opposite to B, we call it as side B, and opposite to side angle C, we call it as side C. So the concept is angle A and side A is always opposite, and that also works for B and C. After you know how to label the triangle, now you can apply the sine rule. Sine rule states that A over sine A equals to B over sine B equals to C over sine C. Now, you can memorize the formula, but I suggest you to understand rather than just memorize the formula. So how to use the formula? How to memorize it easier, or how to understand it without even memorize it? So this is how you use the sine rule. The concept here is just side over sine angle. This is the concept. Side over sine of your angle. And side and angle that I have here has to be opposite. So A over sine A equals to B over sine B equals to C over sine C. So you can memorize it easily by understanding the concept here. Side over sine of the angle has to be opposite, has to be opposite, has to be opposite. Now, you already know the formula. The question is when to use the sine rule, because we have sine rule and cosine rule. You can use sine rule when you have complete pair and half pair. So, for example, I know one side, let's say it's 1 centimeter, and I know the angle that is opposite to that side. We know that as well. We call it as complete pair because we know the side and also the angle that is opposite, one pair, complete pair, because we know them, the value. And then I have half pair. So I know the angle, but I don't know the side that is opposite to that angle. Or the opposite, you know the side, but you don't know the angle. We call it half pair. So we can apply the sine rule. In this case, we have side over sine of the angle. So 1 over sine 30. This is the complete pair part, equals to the side is x over sine of the angle, which is 15 degrees. This is half pair, means that we only know one value, but we don't know the other value. This is the one that we want to find. So you can solve for x by using sine rule. Now, what if I don't have complete pair and half pair? We have the alternative, we call it as the cosine rule. So the second rule is the cosine rule. This is the formula of the cosine rule. You have three versions. The first one is a squared equals to b squared plus c squared minus 2bc cosine a. And you can read it by yourself. We have the b squared version and c squared version. But if you look at the formula, there is a pattern. Let's look at the pattern so you can use it easily. Let's say I have a triangle. And then let's label the angle A, B, and C. And then the side that is opposite to A, we have side A, side B, and side C. Has to be opposite to its angle. Now, this is how we use cosine rule. Let's say I want to find A, and I know B and C here. So we write A squared, the one that we want to find, square, equals to the second side square plus the third side square. Maybe I'll move it down here. Okay. Minus 2 times the second side, the third side. And then put cosine of the angle that is opposite to A, which is the A. So cosine A. So this is how we use the cosine rule. So the first side square equals to second side square plus third side square minus 2 times second side times third side cosine of the angle that is opposite to A, because this is A. If this is B, the angle is B. If the side is C, the angle is C. Look at the pattern. All of them have same pattern. Now, by knowing this, we can use the cosine rule easier. Now, the question is when to use the cosine rule. The first case, when we have all three sides and we want to find an angle. Let's say I have a triangle. I have 7.8, 3.1, 4.2. If we know three sides and we want to find an angle, we can use the cosine rule. So how to find the angle that you want to find? Let's say this is theta. Okay, so how to use cosine rule? Focus on the side that is opposite to the angle that we want to find, which is 3.1. And then we square it. 3.1 square equals to the second side 7.8 square plus the third side 4.2 square minus 2 times the second side 7.8, the third side is 4.2, and then multiply by cosine of our theta. You can solve for theta by using cosine rule. The second case, when we have side angle side next to each other, or I can say cosine hugs the angle. So for example, I have two sides, 7.8 and 3.1, and I know the value of the angle that is in between these two sides. We call it side angle side next to each other, being hugged, the angle being hugged by two sides. If we know this and we want to find the third side, we can use the formula of the cosine. Let's say that this is x. Now, we can find the x by using cosine rule. So it becomes x squared. The first side that we want to find equals to the second side, 7.8 square, plus the third side, 3.1 square, minus 2 times the second side is 7.8, the third side is 3.1, cosine the angle that is opposite to x, which is 30 degrees. Keep in mind that this is side angle side must be next to each other, and you can solve for x by using this cosine rule. So once again, sine and cosine rule also applies to right angle triangle. It applies to all type of triangle, but if you have right angle triangle, I suggest you to use easier way, which is Pythagoras or SOHCAHTOA. The last one is area of a triangle using sine. There are three formula. The first one is half AB sine C, the second one is half BC sine A, and the third one is half CA sine B. But once again, you should know how to use the formula, understand the formula rather than just memorize the formula. So if you have a triangle and you know the value of A and B, and you know the angle between A and B, you need these three information: side angle side, yeah, like before, like in the cosine rule, side angle side. You can use the area of the triangle using sine, which is half times the first side that we know times the second side that we know times sine of the angle between A and B. So this is the formula of the area of a triangle using sine. In the next video, we are going to solve some past paper related to circular measure. Thank you for watching. Don't forget to like, comment, and subscribe. Thank you.